Start with eukaryotic replication. Eukaryotic replication we do not have in SEM 4 in syllabus. Only we have eukaryotic replication difference with prokaryotic replication. Okay, not much idea needed. Okay, but I will give you whatever ideas are opposite of that. Okay, so multi repliconic. Eukaryotic replication is multi-repliconic and bidirectional. So you will say what? Multi-repliconic, then again bidirectional. How is this possible? Both the words have different meaning. Bidirectional means same as prokaryote, happens in two directions from a single origin site. But what is multi-repliconic? Multi-repliconic means in prokaryotic DNA we have ORIC at one location. It has multiple ORIC, matlab multiple site of origin site. Okay, and it is a linear DNA. Eukaryotic replication is linear DNA, not any circular. Okay, linear DNA. Multi-repliconic, bidirectional. Okay, and it is linear DNA. Eukaryotic DNA polymerase. Eukaryotic DNA polymerase, if I talk, eukaryotic DNA polymerase, there are many, more than 15 types. More than 15 types eukaryotic DNA polymerase there. I am going to show you some very important. Okay, Pol alpha, Pol beta, Pol gamma, Pol delta, Pol epsilon, Pol theta, Pol zeta. Okay, so alpha, beta, gamma, delta, epsilon, theta and zeta. These are your eukaryotic DNA polymerase. Some important. There are more than 15 types. What does alpha does? Alpha is primase or primer synthesis. What is beta? Beta is, yes, repair, base excision repair. This one is not in syllabus now, but remember that alpha is, what is alpha? Primer synthesis. Beta, base excision repair. What is gamma? DNA replication in mitochondria, only for mitochondria. This is semi-autonomous organelle. So over there. So this one first is primer synthesis. Pol beta is base excision repair. This is for mitochondrial DNA replication. Then we have Pol delta. What is Pol delta? Lagging strand synthesis. What is Pol epsilon? Leading strand synthesis. What is Pol theta? DNA repair. And what is Pol zeta? What is Pol zeta? What is Pol zeta? It is translation repair. SOS repair system. Yes, translation synthesis SOS repair system. Okay, okay. So again, if I repeat, learn with me. Alpha, let me write it very nicely. Alpha, beta, gamma, alpha, beta, gamma, delta, alpha, beta, gamma, delta, epsilon, theta and zeta. Okay, epsilon, theta and zeta. So most important among these also most important are alpha, delta and epsilon. Alpha is primer synthesis. Beta is base excision repair. Gamma is mitochondrial DNA replication. Delta is lagging strand synthesis. Epsilon is leading strand synthesis. Theta is DNA repair, and zeta is translation synthesis. Translation synthesis. What is this translation synthesis? SOS repair. Okay. Among this, most important, I said alpha, leading strand synthesis, primer synthesis, and lagging strand synthesis. These are most important. So this is your DNA repair. Eukaryotic DNA polymerase. More than 15 types are there. These are the most important among them. And eukaryotic DNA replication is multi-repliconic, multiple ORIC, origin, site of replication, starting, initiation site. It is bidirectional and is linear DNA. Okay. Primer means Pol alpha and primase bind together and form a 4 complex and create a 4-unit protein complex. Pol alpha and primase bind and create a 4-unit protein complex. RNA primer then extend with short DNA stretch. Okay, so Pol alpha and primase create a 4-unit protein complex. RNA primer then extend with short DNA stretch. So this is your eukaryotic DNA replication basic idea. From next class we will start the initiation, we will start the elongation and termination. We will complete in the last class. Okay, thank you.